Hello all. So welcome back. So in this video we'll talk about bioinformatics like Visium fluorescence data with Squidpy. But before that I would like to share my experience on NPTEL exam that I gave on bioinformatics algorithms and applications. Very good subject to get started with. There were a lot of things that was very unknown to me, but I studied from the content that was given to me, and finally I managed to get around 31.5 in proctored exam and 20.94 in the assignments. It's a 12-week long assignment that we have. Like what happens is, like, out of that 12 assignments that you get, around 8 of them are scored. Best of 8 you get the score from that. And let me just tell you that the subject matter and the content was very in-depth and was not so easy to get started with. There are a lot of things that are there, and probably with due course what I will do is that I will cover all of the things as content, as like in Python. I will try to visualize everything. I will share my experience so that somebody who gives the examination next would be able to go through the details of it. Okay, so moving along, in this video what I am trying to do is we will be covering Visium fluorescence data with Squidpy. So my PhD, the subject is bioinformatics AI. So what is Squidpy? Squidpy is a software framework for analysis of spatial omics data. Squidpy supports input from diverse spatial molecular technologies like spot-based, single-cell or subcellular spatial resolution. So building upon the single-cell analysis software ScanPy. So the basis of Squidpy is that it is built on top of ScanPy, and like when you are dealing with bioinformatics data, it's the AND data format that you're looking in. The Squidpy provides efficient data interpretations of these inputs, storing spatial distances between observations in a spatial graph and providing an efficient image representation for high resolution tissue images. Very important for when you're dealing with, like, finding some issues like cancers, dealing with molecular data. It helps very much. Okay, so to install Squidpy, it's a very easy way. If you are using a Windows laptop that I am using, just use pip install Squidpy and you're ready to go with Squidpy itself. So Squidpy has a definite flow that we see, like when you are working with Squidpy, there are different amount of data types that you can work upon, like spatial omics data, Visium, SecFish, MERFish, IMC, CYCF, that is the cytometry data that you have, spatial graph that can be created. You can also have an image container. Then you can find about spatial neighborhood. Like when you are doing analysis, the last part is the analysis part, which is done with the help of machine learning ecosystem. Probably in near future you will see, like, most of my work that I do would be on neural engine that you see in my other laptop that I am working upon. That's been given as a research based laptop for us from the Intel Innovator team. So I'm very thankful to them. You will see more progress on that, and this particular part that you see, the spatial neighborhood, ligand receptor interaction, spatial statistics, that would be done on my neural engine laptop. Okay, so that's the flow. So let's just look at it, how it, in terms of, if you want to find more details on Squidpy, you can get it from this particular link, that's squidpy.stable installation HTML. You get all the details, API, then you have tutorials. I've taken help from the tutorials and created a Streamlit complete application that I would like to present right now. So let's again go back and see how the things are. Okay, so this is the flow that we have already touched upon, like what we are trying to do right now. We are using AND data, ScanPy and Squidpy for loading and analyzing spatial transcriptomics data. So the data that we are loading is a pre-processed image and associated data from the Squidpy datasets. So in the Squidpy library itself, there are a lot of different kind of datasets that are available. We are taking help from that. So these datasets are related to spatial transcriptomics. Okay, so let's just look about it. So if I covered the code over here, first of all, Streamlit is being brought in, pandas is there, matplotlib, and data, then ScanPy and Squidpy. So first we are getting the data from the data sets available from Squidpy, and after that what we are doing is that we are trying to incorporate a way to find out different features of it, and then we map the colors on the user selection. You get a drop down, from there you can select the colors. There is different features of the dataset that's there, you can just do it. We are explicitly setting an NA action because when I was trying to create this particular visualization, I was getting an error, so that this is being explicitly mentioned, the color vector map. We are just ignoring it. Then we are displaying the scatter plot for this. Okay, we have also used a try catch error that can be very helpful when you are dealing with some kind of errors generated when you are doing it in runtime. So let's just look at it. So this is the file sp1. So to run the code, what we are doing is that we are still using streamlit, then run, then sp1.py, that's the file. So let's see how it works. Just wait for it to load. So at the back end you'll see like there are a lot of activities happening when it gets started. Just wait for it to get loaded, because it would go through downloading the data sets and the step-by-step process that happens. So we need to wait for a while. So all the data process has been done. So if we just look at it, visualizing the data itself, we see the scatter plot of spatial 1 and 2. The color segregation has been done using spatial color plot, and this is the data set that we are getting. So we can choose a feature by color of cluster, then we have different tissues, array row, you will see the changes happening. Then again, if I see the genes by count, that also can be seen, and very factually you see that everything changes real time. So it's a real time kind of application that we have built, and it's completely done with Python. So if you can see like genes per count, total counts of the genes, then per counts in top 50 genes, every information that you get from the data set is available, so you can visualize it accordingly. Now again, there are different kind of clustering formats, Leiden. So if I just click on it, you will get the Leiden clustering format, that is the PCA analysis pattern that you see. So it's a very useful tool, and you are ready to get started with it. So that was my video on how do you get started with Squidpy using Streamlit. Probably you liked it, and my journey continues. I need your support. If you like the video, please subscribe to this channel. Thank you.